Okay, nearly finished. Last couple of questions, so they're getting a little bit trickier. This one, the diagram shows a rectangle. Okay, the length of the rectangle is 5 centimeters more than its breadth. There's the breadth, there's the length. This is 5 more. Write down expression. Well, simply then that is going to be x plus 5 because I'm 5 centimeters more. Yeah, so x plus 5. And it's saying, well, if the area is 20, show this. Okay, well, the whole area there's 20. That's fine. How do you get the area of a rectangle? Well, you do length times breadth. So I would say x multiplied by x plus 5 has to be equal to 20. So x squared plus 5x is equal to 20. So then x squared plus 5x take away 20 is equal to 0. So pretty nice marks for that one. A little bit of problem. So a little bit of, contextualizing and thinking. This comes up a lot with rectangles and triangles and things. So again, trickier question that some people don't like. But I think when you see it work through, you're like, okay, that's not too bad. I understand what's going on. And actually here, they've given you the final answer as well. So yeah, if you want to practice them, I think there's some good marks. But don't worry, again, we're getting to the harder stuff where I might not be a big fan of it. Calculate x to 1 decimal place. Now look at that, 4 marks calculating x. Okay, so to solve this, so I'm going to write x squared plus 5x take away 20. X squared plus 5x take away 20. To solve this, I need to use my quadratic formula because I can't find a number that will add to give me this and multiply to give me this. Yeah? No, I can't think of anything. So, and the clue is it says 1 decimal place. So you're going to use your formula negative b plus or minus the square root of b squared minus 4ac over 2a. Now a, b, and c, a is the number in front of x squared, so that's 1. B is the number in front of x, and c is what's left over. If they're written in a different order, it doesn't matter. It's the number in front of x squared that's a, b in front of x, etc. Okay, and it has to be equal to 0. So if we had this bit here, and someone said solve, you have to make sure everything's on one side equal to 0, and then you're ready to solve. A is not 1, b is 5, and there's no c for this. That's not correct. Everything has to be on one side. So now I'm just ready to substitute in. So I'm going to say I've got negative 5 plus or minus the square root. And actually at this point, I tend to do the discriminant just off to one side. So I say, b squared minus 4ac, and that's equal to 5 squared, take away 4 times 1 times negative 20. The 25, take away, that's going to be negative 80. So that's going to be 105 because 2 negatives make a positive. So I tend to do that just on its own. And don't forget, if you've got a positive b squared minus 4ac, that means I've got 2 real and distinct roots. If it's equal to 0, I've got 2 equal roots. If it's less than 0, this will not solve, and it means I've got no roots. So 105 divided by 2 times a, which is just 2. So calculators out. The only thing you need to remember is that you're doing this equation twice. You're doing the negative 5 plus 105 divided by 2, and you're doing negative 5 take away 105 divided by 2. So you should end up with 2.6 and negative 7.6. So that's what the plus or minus is. You break it up to give you 2 different answers. That's your 2 roots of the equation, and don't forget your roots of the equation are just where it crosses the x-axis. So what's my solution though? Does that make sense? Can I have an x is negative 7? Does that make sense? No, it doesn't really make sense. I've solved that, but that answer doesn't actually ring true. So then I need to select this and say nope to that one. Okay. So my answer is 2.6. When I put 2.6 in here, that's going to give me 20. Okay. And that's also going to give me 0 when I do it this way. Yeah. Whereas I've got a negative 7.6, well, it doesn't make any sense. I can't have a negative length. Okay, so that's what your last mark would be for. So you get a mark for your substitution, you get a mark for the discriminant, a mark for this line, and then a mark for selecting the final answer. So you would say, x is equal to 2.6. Don't be lazy like me. Yeah, just explicitly state that. Okay, last few questions. This one, 2 things you have to remember you are not given. Sin x over cos x is equal to tan x. And sin squared x plus cos squared x is equal to 1. So sometimes you see that written as, cos squared x equals 1 take away sine squared x, or sine squared x is 1 take away cos squared x. Oops, so watch out for that. The other thing to note is sine squared x, cos squared x. So for example, sine squared x is just sine x multiplied by sine x. Okay, it's not the x is squared or anything, right? It's just squaring itself as normal. So if you remember these are actually not too bad. So expand and simplify. Okay, well cos, can't do much with that, but I can say tan is sine over cos plus 1. Then I can multiply that out. And in fact, I should really put my x's in. Sorry. So I've got cos x sine x over cos x. Yeah, so that's me just multiplying this and this. And I'm going to add to that cos x. And then you're saying, well, these can cancel out and make 1. So I'm just left with sine x plus cos x. Final answer. Now, people don't always like them. They can be a bit tricky to spot. But really, you see tan, you're subbing that in. You see a squared, you're thinking it's this rule. Okay, so if you can remember these two rules, actually some really nice little marks. People don't be scared of it at all. It's a lot easier than people think. Okay, some of the work in the textbooks to build up to it is quite tricky, but a lot of what I've seen in the past papers isn't too bad. So it's a nice little 2 marks for just these very 2 straightforward rules. Okay. And this question 17 is out, so that means we have finished the paper. So how did you find that then? Let's just go back to the beginning and have a little look. I didn't use my volume of a sphere equation, and I didn't use volume of a pyramid equation, but I used every other, and I used this one. So I used everything except 2 equations. So first of all, that tells me be comfortable with what's on here and how to use it, because it is going to come up. Okay. Next bit, percentages. Yeah, you see a time and a percentage, you're thinking compound. Okay, and watch out for the rounding. This one didn't have rounding, but watch out. This is what it is. I think that technique's quite good for this one, but the point is not to be scared of the big numbers. Okay, and I showed you how to change into scientific notation as well. Factorizing, common factor first always, and then difference of 2 squares or trinomial. I didn't go for the complicated trinomial. And just don't forget, if you were to solve this, that's factorized, but if you solved it, which I've done in red, that gives you the roots of your equation. Sine rule, because there aren't 3 sides. If you've got 3 sides in your question, it's the cosine rule. That's not in it. Use your formula. Don't forget the big square root. X, get your 3 columns, this column would add to 0. This column has always got positives. And watch your on average for the first statement, but not on average for the second statement. Cosine rule, because you've got 3 sides. This one is a great question. You see a kind of part of a circle, you should be thinking sector, which you need to remember, but also don't forget your triangle equation. There's a big triangle right in front of you, so you might want to jot down what you see, and take your time with the questions, but that was possibly a tricky one to spot, but now you've seen it, hopefully you spot it again. Straight line, the number in front of x is the gradient as long as it's in the right form, so you have to rearrange. BODMAS in reverse. Trick to that is there's a big bracket around here though, so you need to get rid of your square term first. And I talked about how that's the same for a division. You need to move the 5 first here. This one, bit of Pythagoras mixed in with a volume. In fact, we did use volume of a cone. I think I took that off, didn't I? Did I take that off? Yeah, sorry. So volume of a cone and a bit of Pythagoras as well. Don't forget your rounding at the end. This wasn't too bad. Keep, flip, change, and then a bit of cancelling out. So remember, your basic fraction rules still apply here. It looks more horrible, but it is still the same. This isn't in it anymore. This one was probably the most technical question, I think. The context made it a bit tricky, but ultimately, you're substituting h in as 115, and then you're rearranging your trig function. Always putting a positive number in here, and from there, use your CAS diagram to get your 2 answers. That's quite a tricky one, I think, but I hope now you've seen it. You would identify it, and it is very, very similar each time. Okay, it's just getting that first step. Okay, this one again, just quadratics. You see shapes, you see x squared, so you should be thinking quadratics. And to solve a quadratic to 1 decimal place, you're using the formula you're given. So that's your clue, 1 decimal place. And very finally, trig functions. Tan is sine over cos, and sine squared plus cos squared is 1. So guys, hope that was helpful, and best of luck.